Hello students. Today we are going to discuss the topic carboxylic acids preparation and properties. What are carboxylic acids? The organic compounds containing carboxylic group are called carboxylic acids. Carboxylic group may contain one carbonyl group and one hydroxyl group. Carboxylic acid. General formula of carboxylic acids is R bond CO bond OH. Now contents of the carboxylic acids. Introduction to carboxylic acids, classification, nomenclature, preparation of carboxylic acid, physical characteristics, chemical properties and applications. A carboxylic acid is an organic compound that contains bond COOH. Bond COOH itself made up of carbonyl group, bond CO bond, hydroxyl group, bond O bond H. General formula of carboxylic acid will be capital R bond C bond O bond OH, where R may be H or alkyl or aryl. Carboxylic acid. This formula, carboxylic acid may be aliphatic or aromatic. Carboxylic acids may be aliphatic acids or aromatic acids. R bond CO bond O bond H is the general formula of aliphatic carboxylic acid, where capital R is equal to H or any alkyl group. Aromatic carboxylic acid, AR bond CO bond O bond H, where AR is an aryl group. It can be further classified as mono, di, tri or polycarboxylic acid depending upon the number of carboxyl groups. In aliphatic carboxylic acids, if R is equal to H, that will be HCOOH formic acid. If R is equal to CH3 bond COOH acetic acid. If R is equal to C2H5 bond COOH propionic acid, and so on. In case of aromatic carboxylic acid, AR means C6H5 bond COOH benzoic acid. Nomenclature. In IUPAC system of nomenclature, carboxylic acids are also called oic acids. These acids derived from the name of alkanes containing the same number of carbon atom as the acid, but the ending E of the alkane name is replaced with suffix oic acid. For example, from methane, methanoic acid, that is HCOOH. From propane, propanoic acid, that is C2H5COOH. For common name, it is named on the basis of source from which it was isolated. Butyric acid, butyrum means butter. Formic acid, formica means ant. Preparation of carboxylic acid. Carboxylic acids can be prepared by different methods. Let us discuss one by one. First one is oxidation of alcohols. Oxidation of alcohols. Primary alcohols and aldehydes are oxidized to their corresponding carboxylic acids. Oxidizing agent like potassium dichromate is used. Example: R bond CH2 bond OH. This is a primary alcohol. This primary alcohol upon oxidation gives an aldehyde R bond CHO. This aldehyde is further oxidized to carboxylic acid R bond COOH. So, in this reaction, primary alcohol upon oxidation gives an aldehyde which is further oxidized to carboxylic acid. So, potassium dichromate is used as an oxidizing agent. In the presence of potassium dichromate, carboxylic acids are prepared from primary alcohols and aldehydes. Example is not mentioned, but we can take the example of primary alcohol as C2H5OH. In place of R, if CH3 is later, CH3CH2OH, that is ethanol or ethyl alcohol. Ethyl alcohol upon oxidation gives acetaldehyde CH3 bond CHO. This acetaldehyde or ethanol upon further oxidation gives acetic acid CH3 bond COOH, which is also called ethanoic acid. From alkane nitride, carboxylic acids can also be prepared from alkane nitrides. Hydrolysis of alkane nitride on boiling with mineral acids or alkalis yield corresponding carboxylic acids. Example: CH3 bond CH2 bond C triple bond N. Propane nitride. Propane nitride upon hydrolysis in the presence of mineral acids gives propanoic acid. In this reaction, C triple bond N is directly converted to COOH. Another example, benzonitride, that is phenyl cyanide or benzonitride. This benzonitride on alkaline hydrolysis gives benzoic acid. In this reaction, bond C triple bond N group is directly converted to bond COOH. So, from alkane nitride, carboxylic acids can be obtained. Carboxylic acids can also be prepared from Grignard reagents. Carboxylic acid can be prepared by the action of Grignard reagent with carbon dioxide. R bond Mg bond X is Grignard reagent, that is alkyl magnesium halide. This alkyl magnesium halide, when treated with O double bond C double bond O, that is carbon dioxide. When an alkyl magnesium halide is treated with carbon dioxide in the presence of triether, gives an intermediate compound which on protonation gives a carboxylic acid R bond COOH. Therefore, carboxylic acid can be prepared by the action of Grignard reagent with carbon dioxide. Carboxylic acids can also be prepared from hydrolysis of esters. Ester on boiling with concentrated sodium hydroxide yield sodium salt of the acid. Salt when treated with dilute HCl gives carboxylic acid. Equation is given RCOOR, carboxylate ester. When RCOOR is treated with NaOH, saponification or hydrolysis gives sodium salt of carboxylic acid R bond COO minus Na plus ROH alcohol. This sodium salt of carboxylic acid on treating with amino acid like dilute HCl gives carboxylic acid. Therefore, carboxylic acid can also be obtained by the hydrolysis of esters. Oxidative cleavage of alkenes. Oxidative cleavage of alkenes. Alkenes, when heated with KMnO4, that is potassium permanganate, are cleaved at the double bond to form carboxylic acid. Carboxylic acid can also be prepared from alkenes. Alkenes, when heated with an oxidizing agent, potassium permanganate, gives a carboxylic acid. Look at the reaction. Propene, CH3 bond, CH double bond CH2. Propene on treating with KMnO4. Propene in the presence of potassium permanganate, cleavage of double bond takes place, resulting in the formation of acetic acid. Double bond is cleaved to form carboxylic acid. CH3COOH plus CO2, acetic acid. So, propene upon oxidation gives ethanoic acid or acetic acid. Similarly, 2-methylbutene 2-methylbutene on oxidation in the presence of KMnO4 gives acetic acid and acetone. So acetic acid can be obtained by the oxidation of 2-methylbutene. Now let us discuss the physical properties of carboxylic acids. Number 1, smell. First three aliphatic acids C1 to C3 are colorless and have pungent smell. First three aliphatic acids have pungent smell, they are colorless. Means ethanoic acid, methanoic acid, ethanoic acid and propanoic acid. C1 to C3 means methanoic acid and ethanoic acid. Methanoic acid, ethanoic acid, and propanoic acid are colorless acids and they have pungent smell. The next three acids are colorless and has unpleasant smell. Next, solubility. Carboxylic acids are soluble in organic solvents. They are also soluble in water due to hydrogen bonding. Like alcohols are soluble in water, carboxylic acids are soluble in water. Hydrogen bonding is responsible for the solubility of carboxylic acids. Carboxylic acid molecules can form hydrogen bonds with water molecules. Therefore, carboxylic acids are soluble in water. As the molecular weight increases, the solubility decreases. So from methanoic acid, ethanoic acid, propanoic acid, as the molecular weight of carboxylic acids increases, the solubility decreases. Look at the boiling point. Boiling point is higher due to hydrogen bonding. Boiling point Boiling point values of carboxylic acids are higher due to hydrogen bonding. These boiling points increase as size increases. It means boiling points increase as molecular weight increases. In this chart, look at the chart of different carboxylic acids are given, their formulae are given, their melting points are given, synonyms are also given. Tetra-decanoic acid, melting point 58 degrees centigrade, myristic acid. Hexadecanoic acid, melting point 63 degrees centigrade. Octadecanoic acid, melting point 71 degrees centigrade, stearic acid. Icosanoic acid, arachidic acid 77 degrees centigrade. Docosanoic acid 80 degrees centigrade is a melting point. Behenic acid. So if you observe the boiling points of these various carboxylic acids, melting points, actually they are not melting points, wrongly it is printed as melting point. Boiling points are continuously increasing. So the reason of increasing boiling points is due to increase of their molecular weights. As the molecular weight of carboxylic acid increases, boiling point also increases. Now melting point. Melting point increases with melting point increases with increase in irregularly with increase in molecular mass. Carboxylic acid with even number have higher melting point than next lower and higher member containing odd number of carbon atoms. Previously we studied boiling points. Boiling points are continuously increasing as the molecular weight of carboxylic acid increases. Whereas in case of melting point, irregularity is observed in melting point of carboxylic acids. Propanoic acid melting point is minus 22 degrees centigrade, whereas the melting point of butanoic acid is minus 6 degrees centigrade, and the melting point of pentanoic acid is minus 36 degrees centigrade. It means that the melting point values are not continuously increasing, but they are having some irregularity in their melting points. Chemical properties. Since carboxylic acid contains both carbonyl group and hydroxyl group, so totally we can divide the chemical reactions of carboxylic acids into three categories. Number 1, reactions involving H atom of carbonyl group. Number 2, reactions involving OH group of carbonyl group. Number 3, reactions involving carboxyl group. Reaction involving H atom of carbonyl group. Number 1, reaction with bases. When a carboxylic acid reacts with a base like strong base like NaOH gives sodium salt of carboxylic acid and water. This reaction is known as neutralization. In this neutralization process, H plus ions from carboxylic acid combine with OH minus ions of NaOH, forming unionized water. Second example, reaction with carbonates and bicarbonates. Carboxylic acid reacts with a carbonate, releasing carbon dioxide. Similarly, carboxylic acid also reacts with the bicarbonate, releasing carbon dioxide. It means that carboxylic acid reacts with carbonates and bicarbonates, releasing CO2 gas. Reaction with metals. Like mineral acids, carboxylic acids also react with the metals, liberating hydrogen gas. All acids means all mineral acids like HCl, H2SO4 react with active metals, liberating hydrogen. Similarly, carboxylic acids, though they are weaker acids than mineral acids, they also react with active metals like sodium, liberating hydrogen gas. 2RCOOH plus 2Na gives rise to 2RCOONA plus H2. Now reaction with PCl5 and SOCl2. It means reaction with phosphorus pentachloride and thionyl chloride. It is nothing but chlorination of carboxylic acid. Here example CH3COOH plus PCl5 gives rise to CH3COCl plus POCl3 plus HCl. One more example, CH3COOH plus SOCl2 gives rise to CH3COCl plus SO2 plus HCl. It means that acetic acid reacts with phosphorus pentachloride, forming acetyl chloride. The second example, acetic acid reacts with thionyl chloride, forming acetyl chloride. So, a formation of acetyl chloride is nothing but chlorination of acetic acid. Formation of ester. When carboxylic acid reacts with an alcohol in the presence of concentrated H2SO4, ester is formed. This reaction is known as esterification. During the process of esterification, OH group of carboxylic acid combines with H of alcohol in the presence of mineral acid like concentrated H2SO4, giving rise to an ester. Bond COOR is a functional group present in esters. So, esters, formation of an ester is called esterification. And esters have pleasant smell and therefore they are used in making perfumes. Reaction with ammonia. Carboxylic acid reacts with ammonia to form ammonia salt, which on heating results in the formation of amide. Example: acetic acid reacts with ammonia forming ammonium acetate. This ammonium acetate, on further heating, loses water and forms acetamide, that is CH3CO and H2. Formation of acid anhydride. Carboxylic acid is dehydrated in the presence of P2O5, that is phosphorus pentoxide. In the presence of phosphorus pentoxide, which is a strong dehydrating agent, from two carboxylic acid molecules, we get acid anhydride. So, acid anhydride is formed by the dehydration of two carboxylic acid molecules. So, carboxylic acid is dehydrated in the presence of P2O5 to give an acid anhydride. Partial reduction of alcohols. Carboxylic acid reacts with lithium aluminum hydride and reduced to alcohols. CH3COOH plus 4H gives rise to CH3CH2OH plus H2O. Carboxylic acid reacts with lithium aluminum hydride to give ethyl alcohol. Here acetic acid upon reduction gives ethanoic acid. This is a partial reduction of acetic acid, because in this reduction process CO group is converted to CH2 group. CO group is converted to CH2 group. Therefore, we call it as a partial reduction. Whereas complete reduction of carboxylic acid gives alkane. Carboxylic acid reacts with hydrogen iodide and red phosphorus gives alkanes. RCOOH plus 6Hi P500 Kelvin RCH3 plus 3H2O plus 3I2. By the usage of this reaction, we can convert a carboxylic acid into alkane. So, if suppose acetic acid is taken, acetic acid reacts with Hi in the presence of red phosphorus at about 500 Kelvin temperature gives ethane. So, complete reduction of carboxylic acid gives alkanes. Let us see the applications of carboxylic acid, means the uses of carboxylic acids. Carboxylic acids are also important in manufacture of greases, crayons and plastics. Higher fatty acids are used in the manufacture of soaps. Means higher carboxylic acids are also called fatty acids, and these higher carboxylic acids such as stearic acid are used in the manufacture of soaps. Organic acids are used in foods, cool drinks, etc. For example, acetic acid is used as vinegar. Organic acids are used for the preparation of many drugs such as aspirin, phenacetin, etc. Acetic acid is used as coagulant in the manufacture of rubber. Acetic acid is used as a coagulant in the manufacture of rubber. Acetic acid is also used in the manufacture of various dyestuffs, perfumes and rayon. Particularly, acetic acid is used in making rayon, perfumes By using acetic acid, we can do esterification process. During the process of esterification, we get an ester, because when acetic acid is treated with ethyl alcohol in the presence of a mineral acid like concentrated H2SO4 gives ethyl acetate. That ethyl acetate possesses pleasant odor, and sweet smell is found in ethyl acetate, and the ethyl acetate, which is called an ester, is used in making perfumes. So these are the various uses of acetic acid. Acetic acid is also one of the important organic compounds which is used in industrial level. Thank you.